STEM fans, are you ready? Let's hear it for the world-class NASA STEM Stars team. From NASA centers across the country, we present Ann Garber.
Good afternoon, everyone. Welcome to the 46th episode of NASA STEM Stars, where we connect students with scientists, innovators, and engineers. I'm Dr. Taisha Batts, and I'll be your host. I'm an education specialist from Langley Research Center. Today, we have with us Ann Garber from Marshall Space Flight Center. Ann, how are you doing today?
Hi, Taisha. I'm doing really well. Thanks for asking, and I'm excited to be here.
And we're excited to have you, Ann. So I just want to remind the students that we'll be hearing about Ann and her amazing work that she does at NASA, a little bit about her background, and we'll also give you a call to action to do as well, so that you can share with us what you've learned back at NASA STEM Stars. So we're going to go ahead and get started. We're going to start out talking about Ann, and we're going to ask her about her hobbies and interests and what she likes to do. So Ann, tell us about yourself and your hobbies.
Okay, well, so I guess we'll just start by mentioning that, my name is Ann Garber. I have a bachelor's degree in aeronautical and astronautical engineering from The Ohio State University, and I work as a project manager at the NASA Marshall Space Flight Center. And we are going to spend a lot of time talking about my job, so it is kind of fun to be able to tell you about some of the things I like to do when I am not working. So first, I really do enjoy quilting. My mother taught me the basics of sewing when I was growing up, and then years later, my mother-in-law taught me the basics of quilting. And I just found that I really took a liking to it. I think because it allows me to exercise my creative side, but putting a quilt top together also requires a lot of precision. Which is kind of right up your alley as an engineer, I think, at least for a lot of us. I am an avid reader, and I also enjoy stargazing. There's a photograph on that page that shows a telescope that my husband just purchased for me, and it's been coming in pieces for the past several weeks, and we finally got the last piece, so I'm really excited to bring that outside and try it out, because I think we'll probably be able to see the astronauts' footprints on the moon with that thing. Joking, but I also enjoy, when we're not being required to social distance, I enjoy playing sports with my friends, volleyball and racquetball in particular. And I do have 3 young daughters, ages 5 and under. So when I'm not working, I am spending a lot of time doing things with them.
So I see that you like to play sports, and you talked about playing sports. So that requires working as a team. Does that translate itself into working at NASA, like that team building? Do you also get that team aspect while you're working at NASA?
Well, no one at NASA really does anything by themselves, right? Almost everything that we do requires teamwork. So I would say that not just at NASA, but in so many jobs, just learning how to function as a team and not rely only on yourself to get something done, that really is an important skill to learn.
And I also think that it's very important, like you said, no matter where you are, whether you're at NASA or you work in another job, that 9 times out of 10, you're going to have that team experience. So having those, those group assignments and working as a team is very important. So we also want to know how exactly you got to where you are. So tell us a little bit about your journey and how you got there.
Sure, Taisha. Well, I started out, I was born and raised in Cincinnati, Ohio, and went to college at The Ohio State University, where, as I mentioned before, I got my degree in aeronautical and astronautical engineering. And that's kind of a mouthful, so we really just call that aerospace engineering for short. And in my final year of college, I applied for and was accepted for a job at the NASA Marshall Space Flight Center. And of course, I was thrilled to get an offer to work at NASA and accepted that offer. So once I graduated, my husband and I moved from Columbus, Ohio to Huntsville, Alabama, where I started working as an engineer in guidance, navigation, and control. Now, when I first hired on at Marshall, it was their policy then, and I think it's still their policy now, that new hires are required to perform, well, not perform, but do a rotation outside their home organization. And that really just means that you leave the group that you were hired into for a period of time, usually at least 3 months, and you go off and you do something else for a while. And the purpose of that is to get you some exposure to the other things that are going on at the center, and just to broaden your horizons a bit. So I did 2 rotations. One was with the NASA Engineering Safety Center, where I was put on a Tiger team that was resolving a problem they'd been having with the space shuttle for quite a while. So this was back when the shuttle was still flying. And I also did a second rotation into nuclear power and propulsion. And in that group, we were designing, building, and testing hardware toward the ultimate goal of eventually being able to fly a small reactor in space. So this was a technology development effort. And as it turned out, nuclear, it was just really, it really connected with me, or I connected with it. I loved it a lot. It was a really good fit for me. So much so that with the blessing of my supervisor from Guidance, Navigation, and Control, I was able to transfer permanently to that team. So the group that hired me let me go, which was really great of them to do. And I worked in nuclear for several years. Following that, well, near the end of that, I also went through a year-long leadership development program where I learned an awful lot and met some really great people, just learning about what it takes to be a leader at NASA. And near the end of that program, I switched jobs and moved into chief engineering, where I went to work on a closed door project. And what that really means is that I can't tell you what we worked on. Those kinds of projects are not very common at NASA, but every now and then there is the need for those. So did that for a while, and then at the end of that work, I moved into the International Space Station Project Office at Marshall. And that's when I really transitioned from being an engineer to working in project management.
What kind of skills did you learn in that leadership training that helps you do the job that you do now?
Well, we covered an awful lot in that year. It was a year in which you spent 25% of your time in training and the rest of your time doing your regular job. But one of the things that stuck the most with me was learning more about myself. We took some personality tests. We talked about strengths and weaknesses and how to identify those. And it really helped me understand better why, or I should say, how I relate to people the way I do and how I relate to the world the way that I do. And it was just really eye-opening to me. It helped me understand why I interacted with certain team members the way I did, and just how I could communicate better with those around me. Because I think that any leader at NASA needs to learn how to be a good communicator. It's a really key skill to have.
And that's great. That's wonderful that you talked about communication, because that is the major skill that no matter what you do, that's important for you to have, is to be able to communicate with people. So one of the students, and we're going to actually talk about this in a minute, but one of the students asked, what kind of degree do you have to be a project manager? So can you kind of elaborate on, what you would need to take in school, or is there a degree that leads you to project management?
You can come to project management in many different ways. You don't have to have a degree in project management itself in order to work as a project manager. My experience was that it was actually very beneficial to have a degree other than in project management. I believe there are advanced degrees in project management. I'm not certain about bachelor's degrees, to tell you the truth, or undergraduate degrees. But I think once you've learned how to work on a team and be part of that team, that just helps prepare you better to eventually maybe lead that team or manage the entire project. So yes, there are advanced degrees you can get in managing projects, because the more you get into it, the more you learn just how much there is to know about managing a project effectively. But you don't have to have a baseline degree in project management in order to do it.
And that's good to know that, your leadership skills that you learned allow you to move into project manager, which is actually the next thing that we're going to talk about. So, what exactly is a project manager, and what does a project manager actually do?
So no matter where you work, you could work for NASA or the military or a company like Walmart or Coca-Cola. Project managers basically do the same thing. The project manager is responsible to plan, organize, and direct a project to completion. And to explain what that really means, I'm going to use an example. So say, Taisha, you came to me and said, Anne, I want you to build me a robot that can walk my dog for me. Well, that's the project. Design, build, and deliver you a dog walking robot. We'd then have to have some conversations about some details. You'd have to tell me things like, here's how long the batteries have to last before they need to be recharged. Here's how fast the robot has to be able to walk. It can't be any bigger than 5 feet tall. I want it to be green. Things like that, those are called requirements. Those are the details that will help the person running the project design and deliver you the kind of thing that you have in your mind. It helps define all that. You would tell me things like, I need to have this delivered to me within 3 months, and I'm going to give you $2,000 to buy parts for it. So right there, I've got my schedule and I've got my budget. We would have to consider safety when designing this robot, safety of the dog, safety of the other people that are on the sidewalk when the robot's walking the dog. I'd have to be having conversations with you and other people that have an interest in how this project is going during the whole process. So that's the kind of thing that a project manager does. We want to make sure that ultimately you get the thing that you wanted, it meets your requirements. We do it on time, we do it for the amount of money we've been given, and we do it safely, and we're communicating the whole time.
So that's great. So I can come to you. I need somebody a robot to wash dishes. But you talked about time management, and that's very important. And for students, they have particular projects that they have to do that have to be on time. So when you're talking about time management, what advice would you give the students about, I have this project due at this time, what should I do first?
So I might give two pieces of advice. The first would be, if you're working on something bigger, that might take a while to finish from start to end, break it into little pieces. And then each little piece, you're going to assign it a duration. You're going to know how long it'll take you to do that task. And when you put them all end to end, that builds your schedule. You'll have all the work laid out in little workable pieces from start to finish, and you just tackle one at a time. And as long as you're keeping up, and finishing each task on time, ultimately you will finish the project on time. The other piece of advice I would give is try not to procrastinate. Procrastination is a problem of mine. That can be the way that I deal with not wanting to do something that I find stressful. But a way to handle that is, set aside some time for yourself every so often to work on the thing that you don't want to work on. And you'll be surprised at how fast you can get it done if you just set aside that time to force yourself to just get through it one piece at a time.
And that's great advice. And so we know that you're a project manager, and we know that you are an MLSG project manager. So talk about exactly what that is and what that stands for.
So MLSG, that's the Microgravity and Life Sciences Glove Box Project. And we use a lot of acronyms at NASA, and you can, I guess, see why when that's the name of your project. You want to shorten it down a little bit. So my job is to manage 2 glove boxes on the International Space Station. And I'll talk more about what that really means on a daily basis for me, but I want to explain what a glove box is. A glove box is essentially a box of whatever size, usually with at least one clear wall so you can see inside it. And it will also have at least one pair of gloves mounted to one of the walls, at least one of the walls of the glove box. And you can see in the picture here, we've got an astronaut on the space station, and he's doing some work in one of our glove boxes, the Life Sciences glove box. That's the LSG part. And you can see that he has put his hands into a pair of gloves that are attached to the window, the front window of the glove box. And he's doing something with the hardware inside. You can see there's some tools in there, some scissors and some other things, and he's manipulating a piece of hardware there in the middle. And he's doing all of that without touching that hardware with his bare hands. So the whole point of a glove box is to isolate the astronauts from whatever is inside the glove box. And it actually works the other way too. It does also isolate the thing in the glove box from whatever is outside the glove box. So it's all about isolation and containment.
Oh, and that's fascinating. And I know that you're talking about, the MLSG, and that there are actually glove boxes on the International Space Station. So I know that we have another PowerPoint slide where you're going to talk a little bit about those glove boxes that are on the ISS.
Yes, so we do have two glove boxes. One is called the Microgravity Science Glove Box, or MSG, and the arrow there is just showing you roughly where it's located. It's in the US lab node. And then there's LSG, the Life Sciences Glove Box, and it's located in the Japanese module. I was going to tell you also that just on a daily basis, like what does it mean to manage this project? What we have to do, or what I have to do ultimately, is first to ensure that those glove boxes are working and that they are ready for the crew to use, the astronauts, when they're ready to use them. I also have to make sure that they are ready for the payloads to go into when the payloads are ready. And the payload is what we call, that's another word for the science that goes inside the glove box. My project is also responsible for helping those payloads get ready to go into the glove boxes, and we call that process integration. I have to do all of this on time and within my budget. And I'm also constantly just integrating my team, helping my team work together and to make sure there are no obstacles to getting their work done. And my team includes people from engineering, it includes safety, and it also includes personnel from the Payload Operations and Integration Center, or the POIC. And those are the folks that actually, those are the flight controllers that send commands to the glove boxes on the space station and talk with the crew when they're doing the science.
So that's great. And so I know that you talked about the payload and the microgravity. And just to be clear, some students might not understand what you mean when you're talking about microgravity. So what do you mean when you're talking about them doing experiments using microgravity?
So a lot of folks would say that colloquially that the astronauts on the space station and the space station itself is in zero gravity, and that's not really true. The space station is, and the crew inside and everything inside it are in free fall effectively around the Earth. They're in orbit around the Earth, which means they are falling toward the Earth, but they're never hitting it. They're moving at such a speed that they're in orbit. So we call that microgravity. There is a small amount of gravity on the station, but if you're up there, you're going to be floating around. It's going to feel like that there's no gravity at all. And that provides a really interesting place to perform research, just to see how being in that kind of environment affects your science and affects your results.
That's great. It's wonderful to know that. And actually, one of the students had a question, which is what you're going to talk about next. And they wanted to know, what kind of experiments would you see in glove boxes? And I think that you have a slide that talks to what kind of experiments actually go up to the International Space Station.
Yes, I do have a slide about that, and I'll preface this by saying that the two glove boxes, they look really similar. They're a little bit different. They were both designed and built by European companies. MSG was really designed for physical science payloads. Those are going to be things like burning things in space. So confined combustion, as you see on this slide, that was an experiment where they burned a series of materials in the glove box just to see how the flame would propagate, what it looked like, how long it took for the flame to extinguish itself, that kind of thing. ZBOT was another physical science payload that was watching fluid slosh in a tank, and that's important when you're designing propellant systems for spacecraft. It's important to know how that works. 3D printing and SUBSA, those are two more physical science payloads. 3D printing, that was an experiment where we used a 3D printer in the glove box to make a part. And you can see how that could be important if you were maybe, say you're living on Mars, you can't bring everything you might possibly need with you. So you want to be able to make some things there that you might need. SUBSA is a furnace that they use to grow crystals. That's another physical science experiment. And then by contrast, the Life Sciences glove box, that was really designed to hold biological research. And that means things like animals, growing plants, microbiology, looking at cells from things that are alive or were alive, looking at bacteria, doing experiments with those kinds of things. That's all life science, and that's what LSG was built for. And there's two examples of that on this slide also. You can see rodent research. We've done a lot of experiments with mice in our glove boxes, and plenty of microbiology research as well.
So is there a common person or a common department that actually gives the go-ahead? How do you choose what science experiments are going into the International Space Station?
So that is one thing that that's really a combination of the organizations that fund the research, there's the national laboratories, if you've ever heard of those, they fund some of the research. NASA funds some of this research, meaning they pay for it. And there are experiments from our international partners like ESA, the European Space Agency, and JAXA, the Japanese Space Agency. Those groups help decide with the amount of time they've been allotted and the amount of space they've been allotted on space station, what science is the most important to them. So one thing that my team actually doesn't do is decide what payloads get to go in. We don't plan that, but the space station program helps with that, and then also the people who are paying for that research, they help decide what's the most important science for them to do.
Okay, so yeah, it's not just one person that decides. It's a multitude of characteristics that decide what gets to go up for the payload. And so one student had a question, Miguel had a question about being an engineer and about how many years it actually takes for school to actually be an engineer. So can you kind of tell us how long it took you to be an engineer, and then if you did an internship or anything like that for Miguel?
I would love to talk about this. So, yes, it took me 5 years of undergraduate to get my bachelor's degree. Now, most schools you can do it in 4, and I could have done it in 4 if I had decided that I wanted to be an aerospace engineer right off the bat. But I didn't know that. I just started just in the College of Engineering, generic. I hadn't decided on an actual discipline. And by discipline, I mean mechanical, electrical, aerospace, computer, welding. There's welding engineering too. I hadn't decided on what that would be. So by the time I chose aerospace engineering, I didn't choose that until my sophomore year. And it was a small major, so they only offered each class in aerospace once a year. So if it takes you 4 years to get through and you don't decide until your second year what your real discipline is going to be, well, it's going to take you 5 years to get through. So I did do that. And because I already knew it was going to take me 5 years to get through, I decided to do internships in the summer instead of co-oping, because co-oping, when you co-op, you actually work during some of your semesters when you would normally be in school, and that just lengthens your time as an undergraduate. So I just chose to go that route, interning instead of co-oping. Was there more to his question that I can answer, Taisha, or did I capture everything?
No, you captured everything. He just wanted to know how long it took you to go to be an engineer, and you talked about how it normally takes 4 years, but sometimes, and I know this from experience, when you first get to school, you haven't decided what you're going to major in. So he wanted to know about that. And you actually went through the difference between internships and co-ops, which is very good because a lot of students know about internships, but they don't know about co-ops. So you actually answered above and beyond. So that was great. So I know that kind of leads us to, what exactly is your work life like at NASA? How wonderful is it?
I can't lie. I love working at NASA. It really has been a dream job for me. It's a challenge. There's always something new to do. Even though there are a lot of things that you do every day that are the same, we have a lot of the same meetings. I have a lot of the same tasks to do from month to month. We're always, even on my own project, there's always something new going on. And when you look at my career path, you can see that I've done a lot of different things. I went from guidance, navigation, and control, which was basically a lot of computer programming. I was writing a lot of code, to working on the space shuttle hardware, to working in nuclear, to to a classified project. I've done a lot of different things. So I've always had a challenge, which has always helped me feel that I've been learning and growing and becoming better at my job, whatever that job happened to be. I've also found my work at NASA to be really rewarding. It's really fantastic to be part of something that you feel is bigger than yourself. Building and flying rockets and operating things on the International Space Station is so much bigger than myself. It just feels really fantastic to be a part of that. And I like being a civil servant. We do this for the good of the American people and for the benefit of the whole world. And it really feels rewarding to be doing something it feels noble. I can't think of another way to put that. And I find that very satisfying. And it's a lot of fun. I like what I do. It's interesting. I've gotten to go to some really fantastic places and meet some incredible people and just see some incredible things. And it's been so much fun. I wouldn't trade these years of work life that I've had for anything.
And that's great. And you talked about traveling. I know that some students feel like, or might think that you just stay at one center the whole time and that's all you do at NASA. So have you had a chance to go to other centers?
I have. I've gone to the Kennedy Space Center in Florida. I've been to the Johnson Space Center in Houston. I've been to Glenn in Cleveland, the Jet Propulsion Laboratory in California. I've been to headquarters in Washington, D.C., Wallops in Virginia. I've been to a lot of places. And you also get to travel if you go to conferences, for example, and you present papers on your work. I've done that, been to many different cities for that reason. I've even been overseas to meet with the companies and folks from those companies who built and helped sustain our glove boxes. So yes, you do get to travel when you work at NASA, and it's a great way to see different parts of the world.
Well, you definitely went to a lot of different centers. I've gone to Wallops before and I've gone to Langley, but not as many as you have gone. So, a question was about the best advice that you got from a mentor. Can you think back and see about what was the best piece of advice that you either got from a mentor or a teacher that helped you through with your career?
I think the best piece of advice I ever got was not to be afraid to make a change, which fortunately at NASA has not proven to be difficult to do. Like I mentioned before, if you look at my career path, I've really done a lot of different things that on the surface might not look like have much in common with each other, but that's been very possible to do. And I think, especially having wound up, if you're going to wind up in something like chief engineering or project management, I think it's good to have a broad range of experiences in your career, rather than maybe just being stovepiped into just one thing. That's just my opinion. But I think that was really good advice. Just don't be afraid to make a change, because even if you make a change into something that you don't like very much, which has happened to me, you'll learn something from it and you can always make another change. You'll learn and grow from everything that you do.
And I think that that's important with the change, just not be afraid to make that change, whatever it is that it's going to be. And so, speaking of that, we are going to talk about the students' opportunities to get involved today and what the students' call of action is. So, we're going to talk about what your call of action is. Today, we're celebrating ISS and the 20th celebration with ISS, talking about payloads and glove boxes. And so today, your call to action is to actually create a international or ISS robotic arm, and you're going to see whether or not you can grapple that. So if you actually make that design, don't forget to share it with us with the hashtag NextGenSTEM so we can see what you're actually going to create. And so we want to tell you what's coming up next with NASA STEMstars. And so next Wednesday, we have Hortense Diggs that's coming to us. And she is the director of the Office of Communication and Public Engagement. And she'll be with us next week on NASA STEMstars, March the 17th at 2 o'clock. So before we leave today, we just want to thank Anne for sharing this experience with us. And if you could leave the students with one piece of advice, let them know what that would be.
If I was going to give any advice to your students, it would be try to find out what it is that you're most passionate about and see if you can turn that into a career. Because if you can find something that you really love to do, you're going to spend a lot of time as an adult working and just earning a living. And if you can find something to do that you really enjoy, you're going to like getting up and going to work every day. And it's not going to be so much work as it will be a combination of work and fun and challenge and reward. So find something you love and see if you can make a job out of that for yourself. And I think you'll increase your happiness.
And that's wonderful, and that's important to make sure that whatever you do, it's something that you love. So we want to thank Anne for joining us today. And again, we can't wait to see you on the next NASA STEMstars. So don't forget to subscribe. Once you subscribe, you'll get all of the updates of the new NASA STEMstars. So we can't wait to see you next week. And thank you again, Anne, for being with us. Have an amazing day.
Thank you, Taisha. Thanks for having me.